Have you ever wondered what would happen if the very star that gives us life, the sun, just vanished? Not a warning, not a slow fade, but poof, gone. How long would we notice? How long could Earth survive? And what would happen to the very fabric of space-time around us? The answer is stranger and far more terrifying than anything you might imagine. Imagine, for a moment, the very star that defines life on Earth, the sun, suddenly disappearing. Not gradually fading away, not dimming over millions of years, but vanishing instantaneously. The first thing to grasp is the sun's role as the gravitational anchor of the solar system. Gravity, often overlooked in everyday life, is the invisible hand that shapes the motions of planets, moons, asteroids, and comets. It is the quiet but relentless force that ensures our world follows a predictable orbit, keeps the moon tethered, and prevents Earth from wandering aimlessly into the cold void of space. The sun's mass is more than 300,000 times that of Earth, and it creates the gravitational well that our planet and the rest of the solar system inhabit. If the sun were suddenly gone, that gravitational tether would vanish as well. Earth would no longer travel in its elegant elliptical orbit, but would instead shoot off in a straight line, tangent to the path it was following at the moment of disappearance. This is not a gentle drift. The speed of Earth as it hurtles forward is roughly 30 kilometers per second, an unimaginable velocity in human terms. Our planet would be cast into a dark, frozen trajectory, spinning through interstellar space with no compass, no light, and no warmth. Other planets would experience the same fate. Mars, Jupiter, Saturn all would leave their familiar paths, drifting independently, potentially colliding with other planets, moons, or even asteroids in their wake. The solar system, which we take for granted as orderly and predictable, would devolve into chaos, a collection of celestial objects flung into the void without direction or purpose. The disappearance of the sun would turn the precise ballet of planetary motion into an unpredictable cosmic scatter. Even as gravity's disappearance sets Earth on a deadly course through the cosmos, the consequences would not be immediate for our perception. Light from the sun takes approximately 8 minutes to reach Earth. This means that even if the sun were gone in an instant, we would continue to see it shining in the sky for 8 minutes, oblivious to the reality unfolding. For 8 minutes, life would appear normal. Birds might still chirp, winds would continue to blow, and sunlight would filter through clouds just as it always has, maintaining the illusion that all is right with the world. But then, abruptly, the light would vanish. The familiar blue sky would be replaced by a deep, unbroken blackness. Shadows would disappear. The warmth that sustains life would fade, and the day would become an endless night. This brief delay is a stark reminder that we never experience events instantaneously. On cosmic scales, there is always a lag dictated by the finite speed of light. 8 minutes may seem trivial, but in that time, the solar system has already started reacting to the sun's disappearance. Gravity's influence propagates at the speed of light as well, meaning the planets begin to drift from their orbits at the same time the last photons are leaving the sun. The universe has a built-in delay, a gentle deception, and within those 8 minutes there is an eerie normalcy that lulls the human mind into complacency before the stark truth takes hold. This combination of lost gravity and delayed perception has profound implications. Imagine that for those 8 minutes, we continue with the illusion of stability ocean. Still tide, the air still moves, and satellites in orbit continue their trajectories. But in reality, every object bound by the sun's gravity has already begun to deviate from its orbit. The moon, tied to Earth, would initially continue its orbit around us due to our own gravity, but over time, the altered trajectory of Earth itself would destabilize this relationship. Artificial satellites would follow unpredictable paths, and interplanetary probes would drift, losing their intended courses. The delicate architecture of human technology, from satellites that manage communications and GPS to spacecraft en route to distant planets, would unravel as the invisible anchor of the sun's gravity disappears. The very order of our engineered world, reliant on predictable celestial mechanics, would be compromised. What we perceive as permanence in the heavens is in fact contingent. The sun's disappearance would reveal just how dependent life, technology, and civilization are on the quiet but absolute rule of gravity. The universe operates according to laws indifferent to our convenience or awareness, and it is only by understanding these laws that we can even begin to imagine the scale of what would happen when the sun vanishes. Simultaneously, the 8-minute delay between disappearance and darkness highlights the strange interplay between physics and perception. For a brief moment, humans would continue living in what feels like a normal day, yet the reality of the cosmos would already be unfolding against us. This delay underscores a profound truth. What we perceive is always slightly behind the reality dictated by the universe. Light, gravity, and other fundamental forces propagate at finite speeds, meaning that cosmic events are often only indirectly accessible to our senses. There's a kind of cruel irony in this. By the time we realize the sun is gone, Earth will already be plunging into the cold and chaos of interstellar space. The universe does not accommodate human perception or reaction times. It simply operates according to its laws. Our awareness of events is always lagging behind the events themselves. This introduces a subtle but pervasive form of vulnerability, a sense of helplessness that is uniquely terrifying. We can predict, model, and understand, but we cannot act retroactively. We are bound by the speed at which information reaches us. The sun's disappearance is not merely a catastrophic event, it is a demonstration of the universe's impartiality and the temporal gap between reality and perception. The consequences of lost sunlight extend beyond perception and orbit into the very fabric of life on Earth. For those first 8 minutes, ecosystems would continue their rhythms, unaware of the looming catastrophe. Photosynthesis, the process that sustains plants and, by extension, the entire food chain, would continue uninterrupted for those 8 minutes. But once the sunlight vanished, energy input would stop, initiating a cascade of biological consequences. Temperature regulation, weather systems, and atmospheric dynamics, all powered by solar radiation, would begin to falter immediately, while gravity's disappearance would destabilize planetary motion. The loss of light and heat would render the environment inhospitable at the surface. The 8-minute grace period, while almost imperceptible in human terms, provide a chilling perspective. Our universe operates on scales and speeds that do not align with our sensory experience, and survival is contingent not on understanding alone, but on timing, preparedness, and the alignment of cosmic conditions. In this interplay of gravity, light, and perception, we begin to glimpse why the disappearance of the sun is not just a theoretical curiosity, but one of the most extreme thought experiments imaginable. It exposes the delicate balance of forces that sustain life, the invisibility of those forces in our daily awareness, and the terrifying reality that without the sun, both physics and biology turn immediately against our survival. As Earth begins its trajectory into interstellar space, propelled by the absence of solar gravity, the implications for long-term stability become apparent. Planets no longer follow elliptical orbits, moons may eventually escape their primary planets, and asteroid belts could scatter into unpredictable paths. Even if humans somehow survive the initial plunge into darkness, the disruption of planetary orbits would change the distribution of energy, alter tidal forces, and destabilize climates over time. The sun is not merely a source of heat and light, it is the organizing principle of the solar system. Its sudden removal would render the delicate architecture of planetary motion chaotic, emphasizing how fragile and finely tuned our environment is. The seeming permanence of day and night, seasons, and climate depends entirely on the continued presence of this single star. The disappearance of the sun illuminates not just the dramatic consequences of its absence, but also the extraordinary orchestration of natural laws that allow life to persist under normal conditions. In understanding this, we confront both terror and awe. Terror at the fragility of our existence, and awe at the remarkable precision of cosmic order that sustains life in the first place. In sum, the immediate consequences of the sun vanishing, lost gravity, and the delayed arrival of darkness are enough to destabilize the entire solar system and render Earth a lifeless, drifting object in interstellar space. But within these consequences lies a deeper lesson about the universe. It operates according to immutable laws, indifferent to life, unaware of our presence, and unconcerned with human survival. Gravity holds planets in orbit not because it cares about Earth, but because that is the way physics works. Light reaches our eyes not to warn us, but because that is the finite speed at which information travels, our perception, our survival. and even our understanding are all embedded within these laws. And it is through the study of these forces that we can begin to anticipate the unimaginable. The disappearance of the sun is a terrifying thought experiment precisely because it exposes our vulnerability to the invisibility of fundamental forces and the delicate balance that allows life to exist in an indifferent cosmos. It is a reminder that while we are conscious and capable of understanding the universe, we remain small and fragile players in a drama that unfolds on scales of space, time, energy far beyond human experience. The moment the sun vanishes and Earth is plunged into darkness, the next immediate consequence is the dramatic plunge in temperature. The sun is the ultimate source of warmth for our planet, providing the energy that drives every ecosystem, every weather pattern, and every life process. Without it, Earth would begin cooling at an astonishing rate. Within the first few days, surface temperatures would drop precipitously, initiating a cascade of catastrophic environmental changes. Water, which covers over 70% of the planet, would begin to freeze at the surface, forming a thin but increasingly insulating layer of ice. Beneath that ice, oceans would remain liquid for a time due to residual heat, but the heat flow from the planet's interior is minuscule compared to the sun's input. Within weeks, the oceans would approach temperatures far below the threshold for sustaining life as we know it. The air itself, no longer heated by sunlight, would grow frigid. Vegetation, already starved of light, would succumb to the cold, and the very process of photosynthesis would cease entirely. Animals, adapted to a specific range of temperatures, would face immediate threats of hypothermia, migration failure, or extinction. The freezing of the planet would not be a gradual seasonal shift. It would be abrupt and relentless, leaving no margin for adaptation. Life on the surface would rapidly become untenable, and only the organisms capable of surviving in extreme cold, deep-sea extremophiles, microbes in subterranean environments, or humans in artificial habitats might endure. The terrifying immediacy of temperature collapse demonstrates the crucial role the sun plays not only as a celestial body in the sky, but as the engine that sustains the intricate web of energy that life depends on. Without it, the delicate equilibrium that allows ecosystems to function evaporates, leaving a frozen, silent planet drifting into an endless night. Alongside the plummeting temperatures comes the collapse of the atmosphere's dynamics, a phenomenon we rarely consider, but one that is essential for life as we experience it. Weather, winds, and ocean currents are all powered by solar energy. The sun drives convection in the atmosphere, which redistributes heat from equatorial regions to the poles, generates wind patterns, and helps regulate precipitation cycles. Without solar radiation, these processes would falter almost immediately. The air would stagnate, and winds would diminish as temperature gradients flatten. Clouds, reliant on atmospheric motion and evaporation, would cease to form, leaving the skies unnaturally still. Ocean currents, which depend on wind and solar-induced temperature differences, would slow, disrupting the circulation of nutrients essential for marine ecosystems. The cessation of these flows would amplify the ecological collapse already initiated by freezing temperatures. In essence, the planet would begin to resemble a dead, inert body, devoid of the dynamic systems that have taken billions of years to evolve. The very air we breathe, the weather that shapes life cycles, and the water cycles that sustain ecosystems would all be fundamentally altered in a matter of days. This illustrates a profound truth. The sun is not simply a source of light, but the driving force behind every dynamic process on Earth. Its disappearance would reveal how intricately connected life is to energy flows that we often take for granted. The collapse of atmospheric and oceanic systems is not immediate in its totality, but the process begins almost as soon as the sun's light and heat cease, setting in motion irreversible changes that will determine the fate of every organism on the planet. The combination of freezing temperatures and atmospheric collapse would also have a compounding effect on human society. Civilization, as we understand it, is intricately dependent on the sun, not only for energy in the literal sense, but also for agriculture, infrastructure, and technology. Crops, which rely on sunlight for photosynthesis, would fail almost instantly. Food chains, both natural and human-engineered, would begin to unravel. Livestock would perish as temperatures drop and vegetation dies. Humans, dependent on agriculture and global supply chains, would face immediate scarcity of food and water. Even energy systems, many of which rely on solar input directly or indirectly, would fail, leading to blackouts and technological collapse. Communities would be forced to migrate toward geothermal hotspots or artificially heated shelters, and the struggle for survival would dominate every aspect of existence. The disappearance of the sun would convert the familiar rhythms of life into a relentless fight against freezing, starvation, and ecological collapse. This scenario underscores how deeply human survival is intertwined with solar energy, not as a matter of convenience, but as a fundamental requirement. The fragility of life and civilization becomes painfully clear when the sun is removed from the equation, revealing how dependent we are on a celestial object that, under ordinary circumstances, seems immutable and eternal. These environmental and societal consequences also emphasize the subtle but pervasive role the sun plays in biological and chemical processes. Life on Earth has evolved in synchrony with the sun's cycles, the length of days, the rhythm of seasons, and the intensity of sunlight-shaped biological clocks, reproduction cycles, and migration patterns. The sudden disappearance of sunlight would disrupt these rhythms instantly. Plants and animals would be forced into survival mode, unable to follow the cues they have depended on for millions of years. Microbial life might continue underground or in deep oceans, but complex ecosystems would collapse. Even humans, who can artificially light and heat their environments, would suffer from psychological stress, vitamin deficiencies, and a profound sense of disorientation. The sun's presence is not merely a passive backdrop, it is a fundamental driver of life's timing and organization. Its absence is a reminder of how fragile these systems are, and how quickly they can unravel when the primary energy source that synchronizes the biosphere is removed. The interplay between temperature, atmospheric dynamics, and biological process illustrates a terrifying truth. Life on Earth is not autonomous or resilient in isolation. It is an emergent property of energy input from the sun balanced with gravity and planetary systems. Remove that energy, and the intricate machinery of life grinds to a halt. Beyond the immediate environmental and biological effects, the disappearance of the sun would also have profound consequences for the broader solar system. Earth would drift into interstellar space without its gravitational anchor, and other planets would follow similar fates. The asteroid belt, no longer stabilized by the sun's gravity, might scatter into new trajectories, increasing the likelihood of collisions. Moons, tethered to their parent planets, could be ejected or collide with their hosts. The delicate balance of orbital resonances that maintain the structure of the solar system would collapse. Comets and other small bodies could be flung unpredictably, potentially intersecting Earth's path. While this cosmic chaos unfolds, the Earth's surface continues to cool. Ecosystems collapse, and human survival becomes increasingly untenable. The disappearance of the sun demonstrates how central it is not just to life, but to the structure and stability of the solar system itself. It is the linchpin around which matter and energy are organized, and its absence reveals the fragility of planetary arrangements we often assume to be permanent. The solar system, so ordered and predictable from our vantage point, would suddenly become a vast arena of randomness and instability, with consequences that extend far beyond our immediate perception. Simultaneously, the sun's disappearance highlights a subtle but profound lesson about the interconnectedness of energy, gravity, and life. Temperature and atmospheric circulation are not isolated phenomena. They are part of a complex network that allows Earth to maintain habitable conditions. The sun provides light, which provides warmth, which drives winds, ocean current, and weather systems, which in turn sustain life and influence chemical cycles. Remove that input, and the entire system begins to unravel like a carefully constructed house of cards. Within days to weeks, the surface of the planet becomes inhospitable. Ecosystems collapse, and the intricate dance of life falters. Even the human-engineered systems we rely on, from agriculture to energy distribution, are vulnerable, exposing the fragility of civilization itself. The disappearance of the sun is not just a physical catastrophe, it is an existential demonstration of how delicate the conditions for life truly are. It forces a recognition that every moment of warmth, every ray of sunlight, every stable season is a gift of cosmic precision, and that life, as resilient as it may appear, is inextricably tied to this singular celestial body. In the final analysis of these initial consequences, the freezing temperatures and atmospheric collapse, one sees that the sun is far more than a ball of burning gas in the sky. It is the engine of life, the stabilizer of planetary motion, the regulator of climate, and the synchronizer of biological and chemical processes. Its sudden disappearance would initiate a domino effect that begins with the environment and ripples through ecosystems, societies, and the solar system itself. Life as we know, it is fundamentally dependent on the balance of energy the sun provides, and its removal reveals the terrifying fragility of that balance. The thought experiment is chilling because it illuminates the reality that every process sustaining life, from the rotation of planets to the flow of air and water, is contingent upon the presence of this single star. The sun's disappearance is not simply the loss of light or warmth, it is the unraveling of a cosmic order, the collapse of a carefully maintained system, and a stark reminder of the vulnerability of all life to forces beyond human control. The interplay between temperature and atmospheric dynamics in the absence of the sun provides a glimpse of the broader cosmic reality. Life on Earth is a fragile consequence of precise conditions maintained by forces that operate on scale far larger and more powerful than any human technology or perception. Understanding these consequences is both terrifying and awe-inspiring because it reveals the delicate threads upon which existence hangs. Thread woven from gravity, energy, and time, all anchored by a star that under ordinary circumstances seems eternal, dependable, and unchanging. Once we grasp the immediate and catastrophic environmental effect of the sun's disappearance, the next layer of consequences extends beyond our planet to the solar system itself, highlighting the delicate and intricate cosmic choreography that the sun orchestrates. Planets, moons, asteroids, and comets are all held in carefully balanced orbits by the sun's gravity. Earth's orbit, which seems so constant to our everyday perception, is actually a finely tuned path that depends entirely on the sun's presence. Without it, Earth would no longer travel in a stable ellipse around the star, but would instead move along a straight line tangent to its orbit at the instant of disappearance, hurtling into the void of interstellar space. Other planets would experience the same fate, each flung into trajectories dictated solely by their momentum. At the moment the sun vanished, the asteroid belt, previously held in a relatively stable orbit between Mars and Jupiter, would begin to scatter unpredictably, sending fragments into new paths that might intersect with planets or moons. Moons themselves, which orbit planets due to a combination of the planet's gravity and the sun's stabilizing influence, could be thrown into irregular paths, collide with their parent planets, or even escape entirely into space. The stability we take for granted, from the motions of distant Neptune to the orbits of tiny satellites, is entirely dependent on the gravitational anchor of the sun. Its sudden absence transforms the solar system from an orderly dance into a chaotic scatter of celestial bodies, each following independent paths in a cosmic void, reminding us how much of what we perceive as permanence is contingent on forces far beyond our control. This destabilization is not an abstract concern for astronomers. It has practical consequence for any life or civilizations that might survive on Earth or elsewhere. A drifting planet in interstellar space is cut off from the stabilizing warmth and light of a star, but it is also subject to unpredictable gravitational encounters. Collisions with wandering asteroids or the perturbations of nearby planets could further destabilize its environment. Even distant moons, which provide tidal forces that regulate ocean currents and potentially influence tectonic activity, could be disrupted. The dynamics of planetary systems, which evolve over billions of years under the constant presence of a central star, are suddenly thrown into chaos in a matter of minutes. For humans, the implications are staggering. The survival strategies that might be developed underground or in artificially heated habitats would have to contend not only with freezing temperatures and an atmospheric collapse, but also with the potential for catastrophic impacts and shifts in Earth's orientation and motion. The sun's disappearance exposes the fragility of the planetary architecture that sustains life, revealing how precariously balanced conditions are, even for a planet that has supported life for billions of years. The solar system is not a static backdrop, but a dynamic, finely tuned mechanism, and without its central engine, chaos ensues. Beyond the structural consequences in the solar system, the disappearance of the sun would trigger a rapid collapse of ecosystems on Earth, beginning with the cessation of photosynthesis. Plants, the foundation of virtually every terrestrial food chain, rely on sunlight to convert carbon dioxide and water into energy-rich organic molecules. Without sunlight, this process halts immediately. Herbivores, dependent on plants for sustenance, would begin to starve within days to weeks, and carnivores in turn would lose their food sources. The disruption cascades through every trophic level, destabilizing entire ecosystems. Even microorganisms that rely on photosynthetically derived organic matter would face shortages. The food web, which has evolved over hundreds of millions of years to harness the sun's energy, collapses with astonishing speed. Humans, who depend on crops, livestock, and global supply chains for survival, would confront famine almost immediately. Storage reserves, while helpful, would be limited in duration, and the challenge of surviving in a world without external energy input would test the limits of ingenuity and cooperation. Artificial lighting and controlled environments could provide temporary relief, but sustaining these systems would become increasingly difficult as other resources, including fossil fuels and batteries, were exhausted. The disappearance of the sun, in this sense, is not merely a physical catastrophe, it is an existential threat to the biosphere, to human civilization, and to the intricate systems of life that have evolved under billions of years of solar influence. The collapse of ecosystems is compounded by the severe temperature drop and atmospheric changes that follow the sun's disappearance. Freezing temperatures, already extreme, would continue to plummet, making surface conditions increasingly hostile. Oceans would freeze at the surface, halting nutrient circulation and disrupting marine ecosystems. Weather systems, driven by solar energy, would cease, preventing the redistribution of heat and moisture. Winds, storms, and precipitation patterns, which support both terrestrial and marine life, would vanish, leaving the planet in a stagnant, frozen state. This combination of environmental stresses creates a nearly instantaneous bottleneck for survival. Life forms incapable of enduring extreme cold, darkness, and resource scarcity would perish. Only extremophiles, deep-sea organisms near hydrothermal vents, or humans capable of creating artificial habitats might endure. The fragility of ecosystems underscores the sun's role not just as a provider of light and warmth, but as a regulator of life-supporting processes on a planetary scale. The disappearance of this single star exposes the delicate interdependence of temperature, atmospheric dynamics, ocean currents, and biological processes that together create habitable conditions. The fragility is almost unimaginable. It takes billions of years for life to evolve the intricate interconnections that allow it to thrive, yet all of it can be jeopardized in a matter of minutes without the sun's presence. Human civilization, in particular, would experience profound consequences. Agriculture, the backbone of human societies, is directly dependent on sunlight. Crops would fail immediately, livestock would die from exposure and lack of food and global food distribution systems would collapse under the strain of widespread environmental disruption. Technology, while resilient in some respects, relies on energy sources ultimately derived from the sun. Fossil fuels or stored solar energy, solar panels, hydroelectric systems are influenced by climate patterns initiated by sunlight, and even nuclear power depends on a stable environment for infrastructure and fuel supply. Cities and societies would confront a cascading series of failures, power outages, supply shortages, and mass migration toward areas with geothermal heat or artificially maintained habitats. The psychological and social stress of living in perpetual darkness, combined with the logistical possibility of sustaining large populations, would reshape civilization in ways that are difficult to imagine. Communities would fragment, resource conflicts would arise, and survival would dominate every aspect of life. The disappearance of the sun, in this context, is not simply a scientific thought experiment. It is a lens through which we can understand the extreme dependence of human life on cosmic processes and the narrow margin of safety within which civilization operates. Furthermore, this scenario illustrates the profound interconnection between planetary systems and life itself. The sun is not merely an object in the sky, it is the engine driving atmospheric circulation, ocean currents, climate stability, biological rhythms, and the very chemical processes that sustain life. Its absence would unravel these interconnections, demonstrating that the conditions we take for granted are the product of finely tuned cosmic parameters. Temperature, weather, ecosystems, and human civilization are not independent phenomena, they are emergent. Properties of a complex system centered around a star that, under normal circumstances, seems eternal. The sun's sudden disappearance would reveal the fragility of this system, forcing a recognition that life, technology, and society are contingent on a singular cosmic presence. The profound implications extend beyond physical survival. They challenge our assumptions about permanence, stability, and the reliability of natural systems. In understanding the consequences, we gain insight into the extraordinary balance that sustains life, the vulnerability inherent in any system that depends on a single source of energy, gravity, and order. In exploring the destabilization of the solar system and the collapse of ecosystem, we also confront a deeper lesson about the limits of human preparedness. While technology allows us to mitigate some risks, the sudden absence of the sun represents a scenario that is fundamentally beyond human control. No engineering, no energy storage, and no societal planning could fully offset the loss of the star that organizes the solar system, drives the climate, and fuels life. This thought experiment underscores the limits of human agency in the face of cosmic events. It reminds us that life on Earth is both extraordinarily resilient and incredibly fragile, a temporary phenomenon sustained by precise conditions that are not guaranteed to persist. The disappearance of the sun is not merely a scientific curiosity, it is a meditation on vulnerability, interdependence, and the extraordinary precariousness of life within a vast and indifferent universe. The combination of planetary chaos and ecological collapse demonstrates how intimately our survival is tied. Sun, and how quickly the structures of life and civilization could unravel without its stabilizing influence. Taken together, these consequences, the destabilization of planetary orbits and the collapse of ecosystems, paint a picture of a universe in which human life is extraordinarily contingent. The sun is both anchor and engine, its presence regulating everything from orbital mechanics to photosynthesis. Its disappearance would unravel this order, creating a cascading series of failures in celestial mechanics, climate systems, biological networks, a human civilization. It is a stark illustration of how dependent life is on precise cosmic conditions and how fragile the systems sustaining existence truly are. The consequences are simultaneously awe-inspiring and terrifying, reminding us that the universe operates according to laws that are indifferent to life, and that our survival is contingent on the continued presence of forces and objects we often take for granted. The sun, a seemingly constant presence in the sky, is in fact the linchpin of existence, and contemplating its sudden disappearance allows us to grasp the profound and precarious balance that sustains life on Earth. Beyond the immediate environmental and planetary consequences of the sun disappearing, there lies an equal, profound, and often underappreciated impact: the psychological and societal transformation that would follow. Humans, as a species, have evolved in constant interaction with the cycles of light and darkness imposed by the sun. Our circadian rhythms, sleep-wake cycles, hormonal regulation, and even mental states are intimately linked to exposure to sunlight. The sudden, permanent loss of this celestial cue would not just plunge the world into physical darkness, but into a psychological one as well. The initial shock of perpetual night would induce disorientation on a massive scale. Without day and night, the very markers of time we use to structure our lives would vanish. Humans would struggle to maintain sleep cycles, productivity, and cognitive function. Mood disorders, depression, and anxiety would skyrocket as the biosphere's natural light cues disappear. Beyond individual mental health, the societal fabric would begin to unravel. Communities, which rely on predictable schedules for work, communication, governance, would confront chaos as time itself becomes an abstraction. The absence of sunlight is more than an environmental disaster, it is a disruption to the psychological architecture upon which civilization depends. Families, cities, and nations would need to find new ways to coordinate, survive, and maintain order in an environment devoid of the natural rhythms that have guided life for millennia. Even the simple act of recognizing one's environment would change. Familiar landmarks, once bathed in sunlight, would be cloaked in shadow, altering perception and spatial orientation. The very act of walking outside, of seeing the world as it is, would become foreign, and with it our connection to reality would begin to fray. The long-term consequences for human society would extend even further, shaping culture, technology, and adaptation strategies in profound ways. Humans are extraordinarily adaptable, and our ingenuity in response to catastrophe is remarkable. But the disappearance of the sun is a challenge unlike any other. Artificial lighting, geothermal energy, and underground shelters would become the new norms for survival. Entire generations might be born without ever experiencing natural sunlight, their biology and psychology shaped entirely by artificial environments. Cultural adaptations would emerge to address the constant darkness, new mythologies, art, and social norms that reflect a world without day. The psychological impact would not be limited to fear or anxiety. Humans are creative and resilient, and the extreme circumstances could foster innovation in energy use, architectural design, and community organization. Yet these adaptations would always be underscored by an awareness of vulnerability, a constant reminder of dependence on a star that no longer exists. The disappearance of the sun transforms human existence from a given assumption of safety and continuity into a fragile negotiation with extreme and unyielding conditions. Societies would need to reorganize, not just technologically, but socially and psychologically, finding meaning and function in a universe that no longer provides the most basic environmental constants. The impact on culture, identity, and collective consciousness would be profound, marking a transition from life guided by a familiar celestial body to life defined by survival in perpetual darkness. As we consider the broader cosmic perspective, the disappearance of the sun also highlights humanity's place in the universe and the fragility of our existence on a planetary scale. The sun is a medium-sized star in an incomprehensibly vast galaxy, which itself is just one among hundreds of billions. The sudden loss of this star would emphasize how dependent Earth is on the specific properties of our star and its gravitational, radiative, and stabilizing effects. Planets in other systems may orbit suns that are more massive, smaller, older, or more volatile, and their life-bearing potential is similarly precarious. Observing the sun vanish forces us to confront the reality that our survival is contingent upon the delicate balance of cosmic parameters, distance from our star, orbital stability, solar radiation levels, and planetary composition. These factors combine to create a habitable zone that is both rare and fragile. Life on Earth, then, is not guaranteed but a product of extraordinary circumstances, and the sun's disappearance serves as a stark reminder that our continued existence relies on conditions that could easily change under different cosmic scenarios. The lesson is humbling. Despite all our achievements, knowledge, and technology, the survival of life is inseparable from fundamental astronomical conditions that are beyond human control. The contemplation of a universe without the sun also brings into focus the philosophical and existential implications of living in a cosmos that operates independently of human needs or perceptions. While the immediate catastrophe is the collapse of ecosystems, freezing temperatures, and planetary chaos are dramatic and tangible, there is a subtler terror in realizing that the universe is indifferent. The sun does not vanish out of malice, it would disappear hypothetically because physical laws permit such a thought experiment. Nature operates according to principles that do not prioritize comfort, survival, or awareness. Life and consciousness are emergent phenomena, improbable and delicate, and they persist only under very specific conditions. By imagining a scenario in which the sun ceases to exist, we confront the broader reality that our continued survival is a temporary equilibrium within a vast, impersonal cosmos. Civilization, technology, and culture are astonishing in their complexity, yet they exist atop a foundation of cosmic contingency. The sun's disappearance serves as both a literal and metaphorical illustration of the fragility of life in a universe that follows its own laws and different to human concerns. Moreover, the disappearance of the sun challenges our perception of permanence and security. Humans tend to assume continuity. Day follows night, seasons cycle predictably, and the sun rises reliably. This assumption is ingrained into our biology, our societies, and our psychology. A sudden cessation of sunlight forces us to confront the illusion of permanence. It reveals that stability is contingent upon factors entirely outside human influence. Our sense of security, our ability to plan, and our expectation of environment, reliability are illusions upheld by the continued existence of the sun. When that foundation is removed, the very framework of human understanding and expectation is shattered. The psychological, cultural, and social adaptation to this new reality would be as important as the physical survival strategies we might employ. Humans would need to find ways to maintain coherence in perception, social interaction, and purpose in a world that has lost its central light. The disappearance of the sun, therefore, is not merely a physical catastrophe, but a profound cognitive and existential challenge, forcing us to reconcile with our dependence on external conditions that we cannot control. In exploring these psychological, social, and cosmic consequences, one begins to appreciate the sun not merely as a physical body, but as a central organizing principle for life and civilization. It structures time, sustains ecosystems, stabilizes planetary orbits, and shapes human culture and psychology. Its hypothetical disappearance is more than a thought experiment. It is a lens through which to examine the delicate interplay of physics, biology, and consciousness. The impact spans from immediate environmental collapse to long-term societal transformation, illustrating how tightly interwoven human existence is with a single celestial object. The thought experiment highlights the remarkable resilience and ingenuity of life while simultaneously exposing our vulnerabilities. The disappearance of the sun magnifies both the awe-inspiring order of the cosmos and the terrifying fragility of life that depends on that order. It forces a confrontation with the realization that existence is sustained, not by necessity, but by a fortuitous alignment of cosmic circumstances. Humanity's place in the universe is neither guaranteed nor protected. It is contingent, precarious, and extraordinarily rare. Finally, by considering the disappearance of the sun, we gain insight into the broader lessons of cosmic perspective, the fragility of planetary systems, the interdependence of ecosystems, and the psychological reliance of humans on sunlight all converge to underscore a single theme: life is a delicate emergent phenomenon, sustained by forces far beyond our control. Even in the absence of immediate catastrophe, the subtle destabilization of time, perception, and societal structure reveals that survival is as much a function of understanding and adaptation as it is of raw physical resilience. This thought experiment, terrifying as it is, also illuminates the remarkable precision, stability, and harmony of the solar system under normal conditions. It encourages humility, curiosity, and an appreciation for the extraordinary circumstances that allow life to thrive. While the sun may seem eternal, imagining its disappearance reminds us that cosmic events are indifferent to human concerns and that the persistence of life is an achievement of incredible improbability, a testament to the delicate balance maintained by gravity, energy, and time across the vastness of space. The disappearance of the sun, therefore, is both terrifying and instructive. It challenges our understanding of physics, biology, society, and consciousness. It confronts us with the reality of human fragility, the limits of our control, and the profound interdependence of all systems sustaining life. It is a cosmic wake-up call, reminding us that even the most fundamental aspects of existence, light, warmth, order, and time, are contingent upon forces beyond our influence. In contemplating such a scenario, we gain perspective not only on the universe's power and indifference, but also on the extraordinary resilience and creativity of life in adapting, surviving, and understanding the very cosmos that could, at any moment, render our familiar world unrecognizable. So, after exploring the unimaginable scenario of the sun suddenly disappearing from the collapse of gravity that would send Earth hurtling into space, to the sudden plunge into darkness, the freezing of our planet, the collapse of ecosystems, and the unraveling of human society, we come to a profound realization: the universe is vast, indifferent, and operates according to laws that neither know nor care about human survival. And yet, within this cosmic indifference, life on Earth exists, not by guarantee, but by an extraordinary alignment of circumstances, a delicate balance of forces that has allowed life to flourish against almost impossible odds. The sun, which seems eternal and constant in our everyday experience, is in truth the central anchor of everything we know and depend on: our climate, our biology, our societies, even our perception of time itself. Imagining its disappearance is not just a thought experiment in physics, it is a humbling meditation on fragility, resilience, and the sheer improbability of life. Thank you all for joining me on this journey through the cosmos, for daring to imagine the unimaginable, and for letting curiosity guide you to the edge of understanding. Keep looking up, keep asking questions, and never stop exploring the universe that surrounds us.